Hello, my name is Pavel, and I'm going to tell you about the critical rendering path. The critical rendering path is the sequence of steps the web browser goes through to convert the HTML, CSS, and JavaScript files into pixels to render on the screen. It has several steps, some of which could be performed in parallel to save time, but some parts have to be done consequentially. The critical rendering path is made up of the document object model, CSS object model, render tree, layout, and painting. And the first step is constructing the DOM tree. The document object model is an object-oriented representation of the web page, which can be modified with a scripting language such as JavaScript and represents the document as nodes and objects. And if we want to visit some page, the browser requests the HTML document from the server or local file system and get the following HTML as a response. But what is get the following HTML as a response? Okay, first of all, we get a number of bytes of HTML as response. Then the browser reads and translates them to individual characters based on specified encoding of the file. This action is called conversion. The next step is to transform translated characters into tokens. The browser converts strings of characters into distinct tokens, for example, HTML, body, and other strings within angle brackets. The final input to generate DOM nodes are start tag tokens and end tag tokens. This action is called tokenization. And the last step is to transform tokens into object or DOM nodes which define their properties and rules. A lexical analyzer in the browser is responsible for converting said tokens into nodes. This action is called lexing. The browser builds up the DOM incrementally. That means it can start to parse the HTML as soon as the first part of the code come in, and it will then add nodes to the tree structure as needed. Every time the browser processes HTML markup, it goes through all the steps above. Convert bytes to characters, identify tokens, convert tokens to nodes, and build the DOM tree. This entire process can take some time, especially if we have a large amount of HTML to process. As soon as parser reaches a link with CSS file, construction of CSS object model begins. The CSS object model is a map of all CSS selectors and relevant properties for each other selector in the form of a tree, with a root, node, sibling, child, and other relationships, and is similar to the DOM. But it's also different. Due to the cascading nature of CSS, the CSS object model cannot be constructed incrementally, because subsequent rules may be overwritten, and as a result, the CSS object model gets built as the CSS is parsed, but can't be used to build a render tree until it's completely parsed by the web browser. The CSS object model is render blocking, and the content can be rendered until the CSS object model is complete. The next step is JavaScript running. JavaScript is expected to block the parser, such as the CSS object model, because JavaScript can add nodes to the DOM. This means that the parsing of the HTML document itself is blocked by JavaScript. When the parser reaches a script tag, it stops to fetch and run it. To avoid JavaScript being parser blocking, it can be loaded with the async or defer attributes. But no matter which files, CSS or JS, arrives first in the browser, the CSS has to be parsed first. As soon as the CSS object model is present, the script content can be executed. Only after that, the DOM parser gets unblocked and can finish its work. Once all the parsing is done, the browser has the document object model and CSS object model built. Combining them together gives the render tree. The render tree is the combination of both the DOM and CSS object model trees. To construct the render tree, the browser checks every node, starting from the root of the DOM tree, and determines which CSS rules are attached to each DOM node. Through this process, the render tree only contains nodes and styles required by the visible content. The non-displayed parts of the page don't make it into the render tree, because it only contains the data necessary to draw the page. And any HTML element with its display set to none is not included in the render tree, as well as all its children elements. The next step is layout. Once the render tree is built, laying out a web page becomes possible, and the process is dependent on the size of the screen. This stage calculates the exact position and the size of DOM nodes in the viewport. The viewport meta tag defines the widths of the layout viewports, which impact the layout. Without it, the browser uses the default viewport widths to lay out the web page, which is generally 980 pixels for full-screen browsers. Performance of the layout stage is affected by the DOM, as the more the number of the nodes in the DOM tree, the longer it takes to lay out a web page. And the last point is painting. The last step to rendering a web page is to paint the pixels onto the viewport according to the box model. After painting, only impacted areas of the screen will be repainted, as browsers are optimized to repaint the minimum area required. Okay, let's summary. First of all, we make a request to a server. The second step is the web browser parses HTML document and builds the DOM tree. Then it checks for and parses CSS documents and builds the CSS object model tree. Then it combines DOM and CSS object model tree into a render tree. The next step is to build the layout from the render tree by computing the position and size of each node. And the last point is paint nodes on the screen based on box model. That's all. Thank you for your watching. See ya.